So this is the beginning of thermochemistry chapter, and thermochemistry is you're associating energy changes. So a lot of what we're going to study in this chapter is heat, but it's not the only thing we're going to study. So that's what we're looking at. And when we talk about energy, we're talking about the capacity to do work, and that could be in the physics terms or in the chemistry terms. If you take physics, you will find out that, or you have already taken physics, you'll find out that work is a force times a distance. And literally, if you don't move an object in physics, you're not doing any work. In chemistry, we talk about more work being done by chemical reaction. So is something expanding, is something compressing, that kind of stuff. We also talk about how is energy gained or lost during chemical reactions. So real quick, that we're just going to do like 4 little slides on different types of energy. Our 2 major types of energy are kinetic energy, which you all know is the energy of motion, and then we also have our potential energy, which is our stored energy. So again, if you think back to like 9th grade physical science, you have your kinetic energy is 1/2 mass times velocity squared. Your mass is in kilograms, and your velocity is in meters per second. And again, it just allows it when you do this that your kinetic energy comes out into joules, which is the chemistry and physics unit for energy. So there's just this little web video. It's real fast that shows you just how like you can convert energy back and forth between the two. So we're just going to look at that if it likes us. Okay. Here we go. So, we don't need this. What this is going to show you is just up here in this little circle, it'll show you when kinetic energy is being used and when potential energy is being used. And again, the circle represents like 100%, like you can't have more than that. So you'll see that we convert the two, and you can see that as we're going up, we're building up potential energy because the virtue of thing, we go to kinetic, potential, kinetic, potential, kinetic. And we'll do it one more time just to see how they convert between the two. So when you're writing Sky Rush, you're doing lots of physics. So that's just, you want to make sure you know the difference between the two and how to solve them. We also have radiant energy, which is what we consider our solar energy because it comes from the sun. We have thermal energy, which is one of the lower forms of energy, which is just heat. And in fact, if you ever watch any of those, I like the History Channel. There's one about like the death of the universe. They say that eventually our energy is going to be in the lowest form, which is the thermal energy, and it'll be like not much going on in the universe. And we also have, obviously to us, very important, our chemical energy. And chemical energy is stored in bonds so that we can, that's how the elements actually are held together. And we said before, when we talk about thermodynamics, we're going to be talking about the joule. And 1 joule is 1 kilogram times meters squared over per second squared. If you use the American system, we have also calories, and there's a little c calorie and a big C calorie. A little c calorie is a 4.184 joules. A big C calorie is actually technically a kilocalorie. So when you eat 2,000 calories a day, you're actually eating 2,000 kilocalories, or you're eating 2,000 big C calories a day for it. The next 2 slides are one is just walking you through calculating the kinetic energy of a molecule, and the other one just predicting whether something's potential or kinetic energy. Should be very simple for you. Should just be kind of like getting you back into thinking about energy. So we have an electron here, and we're solving its velocity, and we know that every electron has a mass of 9.107 times 10 to the negative 28 grams, and we know its kinetic energy. And then again, remember, this is just a nice handy-dandy thing that tells you that kinetic energy equals 1/2 mv squared is going to work. So when we cancel everything out, we will get our speed in meters per second. So all I did is I have my kinetic energy equation, 1/2 mv squared. They gave me my joules. That's going to equal 1/2 the mass of my electron. One thing you want to notice, it's in kilograms. and then times v squared, which is our velocity squared. So I divided everything over, got v squared equals, and then I square rooted my v to get my speed. So that electron's moving pretty speedily. So this is a very simple conversion, but again, just relating the two, that if you know one, if you know the mass and you know velocity, you can get kinetic energy and vice versa. The last one is just these different things. So hopefully you can probably just have already done them, but you can do them as we go along. But the first question is, we have two stationary particles that are adjacent to one another. So we want to know, do they have potential energy or kinetic? Since they're not moving, it has to be potential. If we have an arrow moving through the air, that better be kinetic energy since it's movement. If we have water at the top of a waterfall, better be potential. And last but not least, a raindrop falling will be kinetic energy. So just make sure you can tell the difference between the different energy forms and kind of where they come from and what we use the different energy for. And that is it for types of energy.